The purpose of this video is to describe how to find the vertex of an absolute value function. The general equation for an absolute value function, say it's f of x, it's equal to the absolute value of mx plus b plus c. Now this looks very familiar because this is the equation, the slope-intercept form of the equation of a line. We have to note too that this equation for the model absolute value function occurs when the slope does not equal 0. So to find a vertex, first we need to know what a vertex is. So let's talk about that a little bit. If we have a graph here of a absolute value function, the vertex is defined as the minimum or maximum of that function. Let's draw a couple absolute value functions. Let's draw one down here maybe as well. The red one is just flipped about the x-axis as compared with the purple one. So this point right here is what we call the vertex. And this vertex is what we call a minimum. Okay? This vertex is what we call a maximum vertex. You can think of a maximum vertex, well, just imagine that this is a mountain range. And the very top is the maximum, right there. The maximum is where the function goes from increasing to decreasing. It's that point right there. And as well, the minimum, we can think of this as, well, maybe this is kind of like a mountain range, and we have a valley right here. The minimum is that point where we go from decreasing in value, decreasing, to increasing. It's that pivot point right there. So to find the vertex, all we need is to find a point. And the definition of a vertex, again, is the minimum or maximum point of a function. And that point has, well, it has an x and a y, right? This is called a coordinate point. It's also called a ordered pair. So the equation for the vertex of the absolute value function is negative b over m, comma c. So the x value, that's going to be your x part of the coordinate, and the c is going to be the y part of your coordinate. So let's do an example so that you can really get familiar with it. Let's say we have a function g of x, and that function is going to be an absolute value function. And the absolute value function is going to be negative absolute value x plus 1 plus 2. So first we're going to find the vertex by defining, again, the general formula of that. You don't have to write this down every time, but it might help to write it down 1 or 2 times right above the actual function you're trying to find the vertex of. So we know that the vertex is the point negative b over m, comma c. And that is an actual point that we can graph over here. Okay, we need to figure out what that is. So we can map this actually. So the value for c, let's write c down here. The value for C is going to be 2, right? Because we can line up the two equations one on top of the other. The value for C is 2. The value for B is 1. And the value for M is not X. X is a variable. The value for M is going to be that quiet number that doesn't even appear here. It must be inside the absolute value function. And that's going to be the number 1, because 1 times X is X. So the value for M is going to be 1. So let's go ahead and take this equation right here and just plug in our numbers. So we're going to be plotting this point on our graph next door here. And we need to find, well, first of all, what is B? B is 1. And what is M? Well, M is 1 also. And we have to put a negative sign in front of there because it's negative B over M. And then the C value is just going to be this value right here that we defined right here, right? It's going to be 2. So if we simplify this, the point is going to be negative 1 over 1, which is just negative 1, 2. Okay, so this is the vertex of our absolute value function. That's the one we're looking for. So if we go over 1 and up 2, we get a point right here. Now the other thing you might want to say is, well, this function, this original function for g of x, which way does it go? Is this a maximum or a minimum? Is it a max or a min? Let's figure that out. There's one clue in here that tells us if this function is going to be flipped upside down or if it's going to be a v or if it's going to be an upside down v. And that's this right here. This means we have we're doing a flip or a reflection across the x-axis. So it means that our graph is going to have some kind of look like this. Now where these points are here, that's the subject for the next video, and we'll talk about that in a minute.